Hundreds of different devices may be connected to computers. With the introduction of Universal Serial Bus, or USB, several years ago, the number of devices increased dramatically. Today you can connect scanners, printers, keyboards, mice, game controllers, microphones, sound systems, video cameras, and many other devices through USB. This chapter introduces device management through the following topics: understanding device drivers, exploring plug-and-play operations, connecting and managing devices, printers, and system devices. A device driver is a software module that talks to the device and the operating system. They run in kernel mode. All your hardware in your system needs a driver that includes your video, audio, motherboard chipset, network interface cards, storage controllers, USB-based devices, and printers. It's always best to install your motherboard chipset first. There are a few places where you can go to get device drivers. One is your vendor. So the vendor, you can go to the vendor's website. So if you, for instance, if you have an HP printer, you would go to hp.com to download your print driver. Your operating system has drivers built into it, and your computer vendor may have the drivers you need. So if you have a Dell computer, you can go to Dell's website to download the drivers. Sometimes drivers are provided in a compressed archive, such as a zip file, and you must extract them to a folder before installation. In this case, you will need to extract the files to a folder and then use the device manager to install the driver. In the extracted folder, you will find an INF file that provides the details of the driver to the operating system. The process for installing a driver for a newly added device through Device Manager is presented on the slide. Some hardware may require or benefit from additional software. While a device driver is required for the hardware to work, the additional software may add extra capabilities or features. For example, you can install the device driver for a wireless network adapter and use it with the built-in Windows 7 networking features. Alternatively, you can download custom management software for the wireless adapter and use this software to manage wireless connections. The figure shows the built-in wireless network connection manager from Windows 7 with several configured wireless networks. That's in the back. The front figure is an example of a custom third-party network manager used to manage wired and wireless network connections. The Easy Network Manager ships with some Samsung laptops, and it can be downloaded from the Samsung support website if the machine must be reloaded and the Easy Network Manager software is required. Like new driver installations, an update or upgrade of a driver may come as a self-installing executable or as a compressed archive containing the driver. Here we can see a dialog box where you can browse to locate the specific driver file. After upgrading a device driver, your system may begin to experience problems. In such scenarios, you can roll back the device driver. This action simply means that you are reverting the system to the previous device driver. Here we can see the dialog box, and you can see the box that says roll back driver. Since the Windows operating system works on many different types of hardware, it's important that these device drivers are signed. So the signing process allows Microsoft to verify that the device driver is actually going to function properly and not cause any more problems on your system. There's something called a blue screen of death, or BSOD, that occurred quite frequently in the past, and that was because these drivers were not necessarily signed and created problems on your system. Computers use interrupt request, or IRQs, and I/O addresses for communications. The IRQ is used to get the attention of the CPU. When a device needs the attention of the CPU, it places voltage on the interrupt wire or the connection to the CPU. The interrupt wire connects the CPU to an I/O advanced programmable interrupt controller, which is the proxy between the add-on devices and the CPU. Every device must have an IRQ number associated with it so that the CPU knows which device is seeking attention. For example, it is not uncommon for a network interface card to work on IRQ 19 and COM port 1 to work on IRQ 4. The table lists common IRQ assignments in desktops and servers. In the early days of computing, the technician had to manage system resources such as IRQs and I/O addresses. Plug and Play makes all of this easier. Plug and Play was introduced in the 1990s, and Windows 95 was the first Microsoft OS to fully support it. This technology allows for automatic configuration of hardware resources. In the past, you often define the IRQ and I/O addresses for devices using jumpers or dip switches on the physical adapter cards. Today, you simply plug the device in and let the operating system do all the work for you. During the boot process, the Windows Plug and Play implementation ensures that the hardware resources are allocated as necessary for existing devices. However, Plug and Play is also responsible for detecting and responding to device insertions that occur while the system is up and running. Plug and Play detection occurs based on the following process, as illustrated in the slide. If you plan to install devices on a Windows 7 computer, you should be a member of the local administrators group. Only administrators can install device drivers and therefore add new devices that require device driver installation. You have two options for initial device installation: install the driver during device installation or pre-stage the driver before device installation. One of the most important devices used on modern networks is the printer. Printers may be attached locally or they may be on the network, with printing actually taking place on the server. Network printers are those printers that are available on the network. These printers can be made available on the network in one of three primary ways: printer sharing, network printer devices, and networked printers. You'll read about those in the chapter. Each printer on a Windows system has a print queue. The print queue contains the currently printing jobs and the jobs waiting to print. You can access the print queue using devices and printers. Here we can see an image screen capture of a print queue for a printer called Brother MFC 660CN. You can pause, restart, or cancel print jobs in the printer queue. You can also open the Properties page for a job by right-clicking it and selecting Properties. From here you can schedule the job, set a priority, or even view the layout and paper quality settings used when the job was created. This figure shows the Print Job Properties page used to schedule the job or change its priority. More and more organizations are moving to paperless offices. While few truly ever reach paperless at this point, many have greatly reduced their paper needs by printing to various file types. Windows 7 includes a new file type and a viewer for reading such files called the XPS document. In Chapter 11, you'll be reading about understanding device drivers, exploring plug-and-play operations, connecting and managing devices, printers, and system devices.